Today we are going to start with haloalkanes and haloarenes. The replacement of hydrogen atom in an aliphatic or aromatic hydrocarbon by halogen atom results in the formation of alkyl halide or haloalkane and aryl halide or haloarenes respectively. So for example, here is alkane, and if we replace one of the hydrogen with halogen and it is represented by letter X, you will get haloalkane. So let's take an example of alkane. Methane is very common example of alkane and its formula is CH4. So if I replace one of the hydrogen with chlorine, so here I can write I have removed hydrogen and added chlorine in place of hydrogen. So here I will get carbon and it is bonded to 3 hydrogen, and one of the hydrogen is replaced with chlorine, so here chlorine is there. CH4 is the methane, and when you replace chlorine with one of the hydrogen in methane, you will get chloromethane. Chloromethane is the haloalkane. Similarly, when you replace one of the hydrogen from benzene, benzene is C6H6. And there is alternate double and single bond. And every carbon is bonded to one of the hydrogen. So there is hydrogen bonded to each carbon. So if I replace one of the hydrogen with the chlorine, so here I have removed one of the hydrogen and replaced with chlorine. So here I will get benzene, in which one of the hydrogen is replaced with chlorine. So instead of hydrogen there is chlorine. Now this becomes haloarene, or the name of haloarene will be chlorobenzene. This was benzene, and from benzene when you replace one of the hydrogen with halogen, you will get haloarenes. Now continue. Haloalkanes contain halogen atom attached to sp3 hybridized carbon atom of an alkyl group, whereas haloarenes contain halogen atom attached to sp2 hybridized carbon atom of an aryl group. So here when you see chlorine is bonded to this carbon, and this carbon is bonded to 4 sigma bonds. As it is bonded to 4 sigma bonds, the hybridization of this carbon will be sp3. So in haloalkanes, halogen atom bonded to sp3 hybridized carbon. So here it is bonded to sp3 hybridized carbon. And when you see in the haloarenes, here this chlorine is bonded to this carbon, and this carbon is bonded to 3 sigma bonds and 1 pi bond. As it is bonded to 3 sigma bond, the hybridization of this carbon will be sp2. So in case of haloarene, halogen is bonded to sp2 hybridized carbon. Many halogen containing organic compounds occur in nature, and some of these are clinically useful. These classes of compounds find widely application in industries as well as in day-to-day life. They are used as a solvent for relatively non-polar compounds and as a starting material for the synthesis of wide range of organic compounds. So they are used as a solvent for relatively non-polar compounds. So why they are used as a solvent for non-polar compounds? So let's see. So this is the representation of alkyl chain, and here there is chlorine. So the carbon chlorine bond, there is electronegativity difference. There is difference in electronegativity. As there is difference in electronegativity, the carbon halogen bond is polar in nature. But what about the rest of the chain? So this rest of the chain is non-polar. This chain is non-polar. So overall molecule is very less polar, or you can consider it as non-polar molecule. So that's why, as you know, like dissolves like. Like dissolves like. As they are non-polar molecule, they can use as a solvent for relatively non-polar compounds. Chlorine-containing antibiotic chloramphenicol, produced by microorganisms, is very effective for the treatment of typhoid fever. Our body produces iodine-containing hormone thyroxine, the deficiency of which causes a disease called goiter. Synthetic halogen compounds, for example, chloroquine, is used for the treatment of malaria. Halothane is used as an anesthetic during surgery. Certain fully fluorinated compounds are being considered as a potential blood substituent in surgery. In this unit, you will study the important method of preparation, physical and chemical properties, and uses of organohalogen compounds. Classification of haloalkanes and haloarenes. These may be classified as mono, di, or polyhalogen compounds depending on whether they contain one, two, or more halogen atoms in their structure. For example, monohaloalkane, as it contains just halogen atom. Dihaloalkane, here it contains two halogen atoms. Trihaloalkane, as it contains three halogen atoms in their structure. These are the example of alkane, haloalkane. Now come to the example of haloarenes. Here there is one halogen atom bonded to benzene ring. That's why it classified as monohaloarenes. Here there are two halogen atoms bonded to benzene ring. That's why it is dihaloarene. And here, as this benzene ring, it contains three halogen atoms. It is classified as trihaloarenes. Monohalo compounds may further be classified according to the hybridization of carbon to which the halogen atom is bonded. So let's see. Here we are going to discuss the classification on the basis of hybridization of carbon atom to which halogen atom is bonded to. Compound containing sp3 carbon bonded to halogen, where halogen may be fluorine, chlorine, bromine or iodine. First class is alkyl halide or haloalkanes. It is represented by Rx. So we are going to discuss alkyl halide. It is represented by Rx. Here R for alkyl and X is the halogen. In alkyl halide, halogen atom is bonded to the alkyl group. They form homologous series represented by CnH2n plus 1 X. So let's derive this formula. So when you substitute one hydrogen from alkane, you will get alkyl group. For the alkane, you know the formula. What is the formula for alkane? H2n plus 2. And here I asked you to substitute one hydrogen from here. So when you substitute one hydrogen, the formula plus 1. And here we have replaced this hydrogen with the halogen. So H2n plus 1 halogen. So the formula for the alkyl halide. This is the formula for halide. They are further classified as primary, secondary or tertiary according to the nature of carbon to which halogen is attached. If halogen is attached to a primary carbon atom in an alkyl halide, the alkyl halide is called primary alkyl halide or 1-degree alkyl halide. Similarly, if halogen is attached to secondary or tertiary carbon atom, the alkyl halide is called secondary alkyl halide and tertiary alkyl halide respectively. Now let's examine these examples. Here the first structure is classified as primary alkyl halide. Here halogen is bonded to the carbon and this carbon is bonded to one alkyl group. That's why it is called as primary alkyl halide. And this carbon is primary carbon. Here, now come to the second example. This molecule is classified as secondary alkyl halide. Because the carbon to which halogen is bonded, this carbon is bonded to two alkyl groups. That's why this carbon is classified as secondary carbon. And as the halogen bonded to secondary carbon, it is called as secondary alkyl halide. Now come to the third example. Here the halogen is bonded to the carbon and this carbon is bonded to three alkyl groups. That's why this carbon is the tertiary carbon and the alkyl halide is tertiary alkyl halide. Let's try to understand it again. If the carbon is bonded to only one alkyl group and rest of the site is bonded to hydrogen and halogen is bonded to this carbon. So this carbon is bonded to just one alkyl group. That's why the carbon atom is the primary carbon and the alkyl halide is primary alkyl halide. If the carbon to which halogen is bonded to two other alkyl groups and one hydrogen. So the carbon to which halogen is bonded carbon will be the secondary carbon and the alkyl halide will be secondary alkyl halide. Now, if the halogen is bonded to the carbon and this carbon is bonded to three alkyl groups, then the carbon to which halogen is bonded is the tertiary carbon and the molecule will be called as tertiary alkyl halide. So here when you see the hybridization of carbon atom to which halogen is bonded, as this carbon has formed 4 sigma bonds, this carbon also has formed 4 sigma bond and this carbon has also formed 4 sigma bond. As they all are formed 4 sigma bond, the hybridization of this carbon will be sp3. Here also the hybridization will be sp3. So in all the classes of alkyl halide that we just have discussed, here carbon atom to which halogen is bonded is sp3 hybridized carbon. Now come to the another class in which carbon to which halogen is bonded is sp3 hybridized. And it is allylic halide. These are the compounds in which halogen atom is bonded to an sp3 hybridized carbon atom adjacent to the carbon-carbon double bond, that is allylic carbon. First we need to understand the meaning of allylic. What is the allylic position? Allylic carbon. Carbon-carbon double bond is there and the carbon next to carbon-carbon double bond. So this is the carbon. Here this carbon is present next to carbon-carbon double bond as it is said here. sp3 hybridized carbon adjacent to the carbon-carbon double bond. So here this carbon is adjacent to the carbon-carbon double bond and this carbon is called as allylic carbon. And if halogen is bonded to this allylic carbon, it is called as allylic halide. So this molecule will be called as allylic halide. So here when you see the example, it is like this CH2X. So here this is carbon-carbon double bond and this carbon is just next carbon-carbon double bond. So the carbon to which halogen is bonded is position. Now you examine the another example here. This is carbon-carbon double bond and the carbon next to it is the allylic carbon to which halogen is bonded. So this is again allylic halide. Now let's examine the hybridization of the carbon. Now come to the hybridization. This carbon has formed 4 sigma bonds. As it formed 4 sigma bonds, hybridization of this carbon will be sp3. If you see the another example in which cyclohexene is there, here this is double bond and this carbon is bonded to halogen. So the hybridization of this carbon will be, as hydrogen is not written, but hydrogen is there. In the whole structure, hydrogen is not mentioned. This carbon has also formed 4 sigma bonds, so the hybridization of this carbon will be sp. So in allylic halide, halogen atom is bonded to sp3 hybridized carbon atom, which is bonded to carbon-carbon double. Now come to the benzylic halide. These are the compounds in which halogen atom is bonded to an sp3 hybridized carbon atom attached to an aromatic ring. Now let's examine this example. Here this is the benzene ring. There is alternate single and double bond and carbon bonded to this is bonded to another 2 hydrogen is bonded to halogen. Now we need to focus on the carbon to which halogen is bonded. So the carbon to which halogen is bonded. This carbon has formed bond. As it has formed 4 sigma bond, the hybridization will be sp. Now can you classify this carbon as primary, secondary or tertiary? As this carbon is bonded to just another carbon. So that's why this carbon will be the primary carbon and this molecule will be primary haloarene. In the second example, this is the benzene ring. Here alternate single and double bonds are there. Now this carbon is bonded to one R group. This is another R group and here it is bonded to halogen. Now when you examine the carbon to which halogen is bonded, as this carbon is bonded to 1, 2 and this is 3 alpha group. This carbon is tertiary carbon and the molecule will be tertiary haloarene. Now come to the hybridization of the carbon to which halogen is bonded. As it has formed 4 sigma bond, the hybridization will be sp3. Now come to the another class of compound containing sp2 hybridized carbon to which halogen is bonded. sp2 hybridized carbon bonded to halogen. This class includes vinylic halide and aryl halide. So first discuss vinylic halide. These are the compounds in which halogen atom is bonded to the sp2 hybridized carbon atom of the carbon-carbon double bond. Let's examine first example. Here this is carbon which is bonded to another carbon, and now halogen is bonded to this carbon. As this carbon has formed 3 sigma and 1 pi bond, the hybridization of this carbon will be sp2. Now come to the another example. Here the halogen is bonded to this carbon, and this carbon has formed 3 sigma bond and 1 pi bond. As it has formed 3 sigma bond, the hybridization of this carbon will be sp2. Before vinylic, we have discussed allylic. So let's revise it. What is the difference between allylic and vinylic? In allylic, carbon is present adjacent to the carbon which is bonded to double bond. Means here, this carbon which is adjacent to the carbon-carbon double bond is the allylic carbon. So this carbon is the allylic carbon. And in case of vinylic, carbon-carbon double bond. Now let's differentiate between allylic and vinylic. Now let's identify allylic and vinylic carbon. Carbon-carbon double bond, then single bond. So which carbon is allylic and which one is vinylic? So the carbon adjacent to the double bond, this carbon is the allylic carbon. And this carbon or this carbon, so they both are vinylic. If I draw one structure, carbon-carbon double bond, it is CH2, CH, single bond, CH2, and it is bonded to Cl. So this alkyl halide in which halogen is bonded to allylic carbon, this will be allylic halide. In the another example, if I draw CH2, double bond, CH, single bond, Cl. So here chlorine is bonded to the carbon which is vinylic carbon. So this carbon is vinylic carbon. So this molecule will be vinylic halide. Now come to the next class, aryl halide. These are the compounds in which halogen atom is directly bonded to sp2 hybridized carbon atom of an aromatic ring. Here this halogen atom is directly bonded to sp2 hybridized carbon. The hybridization of this carbon will be sp2 as it has formed 3 sigma and 1 pi bond. The hybridization of this carbon will be sp2. In the next example here, this halogen is bonded to this carbon and this carbon has formed 3 sigma and 1 pi bond. So the hybridization of this carbon will be sp2. These are the examples of aryl halide. Before aryl halide, we have discussed benzylic halide. This was the benzylic halide. Benzylic position is the position next to the benzene ring, is the benzylic position. So here halogen atom was bonded to the carbon which is present next to the benzene ring. In aryl halide, halogen atom is directly bonded to the benzene ring and this position is aryl halide. Now come to the nomenclature.